Now, after discussing basics about complex number, their different properties, and the topology and geometry of different regions in the complex plane, now we are going to define our first main object of study of complex analysis, complex functions. Now, before going into the complex part of complex functions, let's first try to understand what is a function. Now, there are many quantities around us that are related with each other. So, for example, if a wind is blowing, then the speed of the wind depends on the temperature and other quantities. So, we can say that the speed of the wind is related to the temperature. Similarly, if a current is flowing in a circuit, then the current I is related with the voltage across the circuit. Okay. Similarly, there are many other factors. Let's consider an example of temperature at different time of a day. So, if I consider temperature, let's say at 9 o'clock in the morning, then the temperature will be different. And if I consider it at 12 p.m., it will be different. And if I consider the temperature at 4 p.m., it will be a different value. So we can say that the temperature is related with time. In fact, temperature depends on time. Okay, so time is basically an independent quantity in this example, but the temperature depends on time. So we can say that temperature is a function of time. And more precisely, when I consider or when I take reading of temperature at any particular time, then it's going to give me precisely one temperature value. And of course, not two values. So we cannot say that at 9 o'clock the temperature is 20 degree and 30 degree. So it is not possible. So it is always going to be one unique output. And of course, if this function is useful, then we should get the temperature value at each and every time. So we can say that this temperature function is basically relating each and every value of the time in one 24-hour period with a unique value of the temperature. So more precisely, we can say that the temperature function T is associating each and every number between 0 and 24, since there are 24 hours in a day. So between each and every number in the closed interval 0 to 24 with a value, unique value between minus 20 degrees C and 50 degrees C. So we can say that this is a temperature function. It gives me a unique output for each and every value of time. So we can say that a temperature is a kind of a machine. It takes input as one quantity and it gives me output as another quantity. So, and these two input and output quantities are related. And how they are related? So it is inside the machine. Okay. So more precisely, what is a function? A function from set A to set B. So in set A we have one quantity and in the set B we have another quantity. And what is the function? So function is relating the quantities in the set A with the quantities in the set B. And what is the rule? So there are two conditions that we impose on this definition such that our function is a useful object. So one of the conditions that we impose that we should get output for each and every input from the set A. So in other words, each element of A is associated to a unique value of B. Okay, so there is the second condition that the output should be unique. And if it is not unique, then the function is not a useful function. Okay, so a function from a set A to set B is a rule that associates a unique value in B for each and every value in A. Now, moving on to complex function. Of course, in calculus, we have learned about functions where the set A and the set B are real numbers. Now we are going to consider functions where set A and set B are going to be complex numbers or subset of complex numbers. Now, why we need complex functions? And since the complex numbers are imaginary numbers, so the complex functions can be said as imaginary functions. Okay, so are they really imaginary, or there are some realities involved with these functions? Now, consider the example of this pendulum. So what is a pendulum? Take a small ball and attach it with a thread, and one end of the thread is fixed. Now, if you move this ball away from this central position and leave it, then it will start this back and forth motion. Now, as the time moves on, the magnitude or the maximum distance of this ball from this central position is going to be decreased. So there are many factors. One of the factors is air friction, and there are some other factors. Now, if you want to completely understand this situation, then we need to model this situation. In other words, we want to write down the quantities, we want to write down the relation between the quantities, and we want to write down the conditions. So if we want to do that, and if we want to use real numbers and real valued functions, then it's going to be a very complicated model. And if we want to simplify the situation, then we are going to need complex valued functions. Now, the next example is basically fluid dynamics. So if we are considering, for example, a fluid in two-dimensional with low viscous number, then we are going to need complex valued functions. And since the fluid is very, very applicable phenomena around us, so for example, starting from oil rigs to the blood flow in our veins, so fluid dynamics is a very real life oriented thing. So and complex valued functions help us in understanding these phenomena. So we can say that these complex valued functions, so they are very, very related to our real life. And in our next example, consider the circuit theory problems. So if we want to solve a circuit, then we are definitely going to need complex valued functions. So in a very simple words, if there are no complex valued functions, then it is not possible. So it was not possible for you to watch me right now. So it is possible due to complex valued functions. Now let's precisely define what is a complex function. So a complex valued function of a complex variable z is a rule that assigns to each value z in a set D a one and only one complex value w. Okay, so in this case, z is the independent variable and w is the dependent variable. And when we give z as input, we get w as an output. And this set D is basically the domain, and D is a subset of complex plane. And this w is known as the image of z under f. Now this set D is basically the domain, and this set where we put all of our image values is known as the range of the function. Now, a complex valued function is also known as mapping or transformation. Now let's consider this simple example of a power function where the rule for relating two complex numbers is we take z as an input and the output is z square. Now in this case, the domain is the entire complex plane and the output is a complex number. Now if I consider the image of, let's say, 1 plus iota, then it is going to be 1 plus iota square, which is equal to 1 plus iota square plus 2 iota. 1 minus 1 plus 2 iota is equal to 2 iota. So that's how we calculate the image of any complex number in this case. And similarly, we can take any complex number, square it, simplify it, and then we will be getting its image value. Now, in the definition of a function, there are two parts. So the one part is, what is the domain? What are the objects that we are going to relate? And the second part is how we are going to relate those objects. So in other words, the rule of the function. So in this previous example, if we consider f of z is equal to z square. So in this case, the domain is C, and the rule for assigning or relating complex numbers is f of z is equal to z square. But if I change this domain, let's consider this domain D to be this open disk of radius 1, and we take the rule to be the same. Okay, so let's consider f1 of z is equal to z square. Now in this case, the function f and f1, they are completely different functions. The rule is the same, but the domains are different. And since there are two main parts of the definition of the function, the domain part and the rule for assigning the elements or relating the elements. So in this case, the rule is the same, the domains are different, so these are two different functions. And similarly, if the domain is same and the rule is different, then once again, they are different functions. Now in this discussion, we learned about why we are going to need complex valued functions. And we precisely defined complex valued function. In our further discussions, we are going to explore further properties of complex valued functions.